Hello, here is lesson 132. So Jace has a yard measuring 24 feet wide and 13 feet long. I'm going to draw a little sketch of his yard. 13 feet wide and 24 feet long. Or he says actually 24 feet wide and 13 feet long. You can switch the width and the length in rectangles. It does not matter. So we want to know the perimeter of the yard. When you see the word perimeter, think about the fence. We want the distance around. So we are going all the way around. 13 plus 24 plus, this is going to be another 13 plus 24. So we add all those up. Let me see, 2 24s is 48 and 2 13s is 26. And it looks like I get 74 feet for the perimeter of the yard. Number 2, the least common multiple of 4 and 19. So least means the lowest, common means the same, and multiple is when we're multiplying. So if we multiply by 4 or multiply by 19, what's the lowest number we can have the same answer if we multiplied something by 4 or 19? So basically we're talking skip counting. We skip count by 4s, we skip count by 19s, and we find the lowest one where they match. So I know my 4s, I could skip count by 4s pretty well, but I don't really know my 19s, so I brought in my giant chart. So these multiplication charts, they have the multiples. That's what these are. So if we look at 4, the first multiple of 4 is 4. 1 times 4 is 4. Second multiple of 4 is 8, because 2 4s makes 8. So these are all the multiples of 4 on and on and on, all the way to the 25th multiple of 4, which is 100. And down below, I have the multiples of 19. The first multiple of 19 is 19, then 38, 57, and so on. They get bigger a lot faster. So basically, I am just taking a look and seeing what matches. So I know there's no 19 in the 4s, because the closest I can get is 20. If I look at 38, looks like I can get 36, but I can't get 38. 57, I can get to 56, but not 57. 76, the fourth multiple of 19. 4 times 19 is 76. There is a match there. Oh, look, it's the 19th multiple of 4. 4 times 19 is 76. So where we match is at 76. That's the lowest multiple of each number that matches. So my least common multiple of 4 and 19 is 76. Okay, the values shown by the models using fractional notation. Let's see, I've got a bunch of halves here. So I could write this as the number of halves. That would be a fraction, right? 1, 2, 3, 4, 5, 6, 7 halves. Some of you may have noticed that, well, those halves go together to make one whole, so I do also have 3 and a half. And I suppose you could have also thought of this as fourths, since this one is done as fourths, and we can do equivalent fractions. So we could even say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 fourths. Also equivalent. All of these are true and correct. As you go on up, usually they will want responses in simplest form, and usually you'll be asked to get to that, 13 and 3 and a half. Number 4, the starting points of the rays. So if you will recall from our geometry lesson, a ray starts at a point, but it doesn't end, it keeps going. So it has an end point and one end, and then it doesn't end the other way. So it starts and then it keeps going. So if we label this x, y, my ray would be x, y. And my starting point there would be right there. That's where that ray starts. Now this picture they gave us is kind of confusing because there are so many dots on some of these lines. So I'm going to name these points so that we can discuss what they mean. This is the reason that we name points, is so that we can talk about them more clearly. So ABC, we'll call this one D, E, and F. So if we start over here at A, can A be the beginning of array? Well, sure it can, because going this way is array. So I could call AB array and say A is the beginning of it. And by the way, I could also call it AE, because here's E right here, and that same ray goes through E. So what about B? Can B be the beginning of a ray? Well, not if it goes to C, because that's a segment, and not if it goes back to A, because that's a segment. But if it goes this way, it is also a ray, so we could call B, E, a ray. Let's see, C cannot be the beginning of a ray, because it ends both ways. That's a segment. BC is a segment. BC is a segment, so C is not starting any rays. Let's look at D. Now, if you have a ray, it has to go through another point. So D can't be a ray going off up that way. That doesn't work. But it can be a ray going this way. So we could say DE is a ray, and it would be the same thing if we called it DF, because that is still all going this way. Whether it starts at D and goes through E or goes through F, it's the same ray. So D can be the beginning. How about E? Can E start a ray? Well, yes, it can. E can go either way. E can go this way. It can be ED. You notice when you write down a ray, you put the letter where the ray starts as the first letter. So DE shows that we're going down towards F, and ED shows that we're going up, away from F. So let me see, and I could do a different ray. I could go with E and go towards F, and that would be ray EF. Okay, what about F? Can F start a ray? Yeah, F can start a ray too, because F could go this way towards D. So we could say FE is a ray, and of course we could also call it FD. So there you go. You could circle every point on this figure except for C, as long as you're clear with which way it's going to make it be a ray. All right, finally, we are at the last one, some addition, 87,132, and we are going to add 50,498. 8 and 2 is 10. 9 and 3 and 1 is 13. That would be a 6. 137,630. 137,630. There you go. There's lesson 132.